Hey, Technorama listeners, this is Chuck, and I am here with a brand new coworker of mine. Actually, he's not brand new, but our relationship here is brand new. And introduce yourself.
My name's Tom Delatush.
And Tom, what have you brought for me today?
I've got a bunch of antique computing instruments.
Now, this is why this piqued my interest. We were talking yesterday about, I brought in a punch card, and that led to Jakarta looms, and that led to the Computer History Museum, and apparently, Tom, you've been there?
I have, twice.
Okay. And not only that, but you've got an interesting connection with them.
Well, I've sold them some items out of my own collection. I collect these antique instruments.
You're a source for the Computer History Museum.
I am.
That must make you older than the history that's in there.
Probably not.
Okay.
I'm also a source for a bunch of other strange people who collect these things as well.
This is awesome. Now, you told me there's some significant value to some of these instruments.
Some of them there is, not all of them. And the value mostly depends on how scarce the item is and how many buyers or potential buyers there are for that kind of an item, sort of the product of the two.
Okay. Now, what have you got for us today?
Well, yesterday you mentioned a sector rule that you saw at the Computer Museum, and I told you I had some, so I brought one of mine in.
Now, sectors are kind of a precursor to the slide rule.
That's right. They're sort of the second stage in these sorts of things. And the one I've got here in my hands is one that comes from the late 1700s, made for the gentlemen of English society from a company called Nairn and Blount, which is kind of the BMW, if you will, of sector rules.
Do you know how to use this instrument?
I do.
Could you do a simple calculation for me?
I could not, but only because I don't have a pair of dividers. There's another piece you're required in order to use this, and actually one other thing I'm going to show you. You have to have a pair of dividers to measure off distances along these lines.
Oh, okay. So would it be like a compass kind of instrument?
Yeah, only if you told a mathematician it was a compass, they'd probably whack you over the head with it. But for them, it's a pair of dividers. Both ends of the dividers have points. There's no pencil to it.
Now, there's some markings on here. What do they signify? What's the significance of those?
Well, in one case, it's just the name of the manufacturer, but that's probably not what you're referring to. There's several scales on here. Each scale is a number line, and some of the scales are logarithmic. That is, the distance between the numbers is proportional to the logarithm of the number. Some of them are related to whether it's like a trigonometric function, like sine or tangent. And others are for more specialized calculations. In the case of this particular sector rule, there's lines on here to help you navigate. So there's specific lines for calculating latitude and longitude from a star chart when you take your position with a sextant.
How do you know the age of this instrument?
This particular one I only know because there's some, in England in particular, there's very good history on the manufacturers and the styles of the things they produced at various times. And in some cases, and in this case in particular, the actual maker who worked at that manufacturer signed it. And we know within a few years when those were made because we know when that maker was working.
This appears to be made out of ivory, is that correct?
It is narwhal ivory. They take it out of the tusk of a narwhal with a brass disc hinge.
I'm noticing that the scales go right into the hinge. That's interesting that they had to etch those very accurately.
The major use of it is fully opened like this to make a longer ruler. So that's not the only use, but that's the major use of it. You can also use this to measure angles, again with a pair of dividers against some of these lines. So that's the reason for the hinge, and it's not just made as one longer rule. But it also, when folded, fit more easily in the gentleman's pocket.
Yeah, it would look kind of funny with a 12-inch ruler sticking out of your shirt.
Yeah. There's an interesting little statistic on these. Somebody way back in the early 1800s took the trouble to go survey the people who own these things to find out how many could use them, and it was only about 10% of the owners. So these were much more a status symbol than they were a practical instrument.
I wasn't aware you could do so many complex computations on there.
Yeah, you multiply, divide, take a logarithm, take an anti-logarithm. You can get powers. You can do all kinds of different trigonometric calculations. And as I mentioned before, those navigation calculations, all on this one. And there were many different models for different purposes. So you could buy one, for instance, that was designed for use by a tax collector. that had tax-related calculations for liquor.
Really?
Yes.
It just had one scale on it that said take everything.
No. I actually have another slide rule I'm going to show you here that was designed for tax collectors. It's far more complicated than you might think.
Oh, let me see. What else do we have?
All right.
I notice you're not handling these with any special white gloves or anything.
No, but I am taking care to keep them clean. I've got them all wrapped in towels here. So this one is a four-sided rule. I forget actually who the maker is. Oh, it's Cook. This is a Cook tax rule designed for the people in England who calculated the taxes on liquor. And those calculations involved several things that you might not expect. So, for instance, the first thing it does is calculate the volume of liquid in a barrel based on a dipstick that goes into the barrel to see how deep the liquid is, the shape of the barrel, and the size of the barrel. So all of those factors can be taken into account. You move the slide rule around a little bit, and you get the total volume of liquid.
Oh, that's pretty interesting because all you'd have is the depth and the radius, and there you go.
And actually the shape. There were 3 standard shapes for the barrels, and each of them has a separate set of scales on here to calculate the volume.
When I think of a barrel, I only think of one shape. What other shapes could there be?
There's a kind of barrel that's made by 2 cones joined together. There's another kind of barrel that's sort of like a sphere in the middle with 2 cones attached to the end, and then there's a perfectly cylindrical barrel. All of them are common.
Now, this looks like a slide rule with a slide rule on each side. It's kind of
It's a four-sided.
a four-sided slide.
And there's another trick to it. It's designed to be used actually like this.
So you take one slide out and put it end to end with another. And
Yeah.
what value does that give you?
It lets you, wherever you move it, you can always read the answer off of it. So if it didn't have this, some of the answers wouldn't be readable because it's missing and it's moved off to one side. But like this, you can do
Got
it
a much
easily.
larger scale to work with.
Yep.
Neat.
So after you get the volume, the next thing you need to know is how much alcohol is in that volume. And the way they did that is they had an instrument called a saccharometer, measures the sugar in the liquor.
Is that similar to like a hydrometer today?
No. Saccharometer actually is a much more complicated instrument. It involves burning a small sample of the liquor and measuring the residue that comes out of that. They measure the sugar content, they measure the temperature of it, and they measure the specific density, feed all of those pieces of information into the slide rule, multiply by the volume, and they get the amount of alcohol. And then the tax rate, the tax was a specific rate per volume of alcohol. And this slide rule let them calculate all of that.
That's amazing. All out of this instrument that looks like a big fat ruler.
That use for this instrument was actually what drove the development of the slide rule. That was the first time there was ever a need for repeated, complicated calculations, and that's actually what drove the development of this. And then after they developed it for this purpose, they started using them for all sorts of other things.
Now, this looks more complex than a slide rule. What is the main difference between this instrument and a slide rule?
This actually isn't any more complex. It's just a slide rule with lots of scales, and they used all 4 sides to put all the scales. You could have done the same thing with a big flat slide rule.
I also noticed that it doesn't have a slide rule. You typically have the sliding red line.
A cursor, that's called.
Oh, good name for it.
Yeah. And the only reason you don't need that is because with this 4-sided affair, the slide is always very close to, in proximity, the scale you're trying to read against it.
Okay.
But where the big flat slide rule, the scale could be at some distance, and the cursor was very useful for figuring that out.
Sure. Okay. Well, neat. So flatten one of these out and you've got a slide rule.
Yeah.
What else do we have? You've got a number of things.
Got
This
a
is like
bunch of
unwrapping
rules.
Christmas presents. Yeah, this one's rather long.
This is the predecessor to sector rules.
There was a predecessor to sectors.
This was the very first calculating instrument that used logarithms.
Okay, now this looks like about a 2-foot ruler with, we've got, take it inches on the top, and then like a table on the left, and some other markings on the right that are of varying gradient. Oh, we've got one marked RUMCHO, and I take the last 2 as sine and tangent. Not sure what that last bottom one
Sine
is.
times tangent.
How handy.
A frequent product in calculation.
Oh,
now.
and there's stuff on the back.
Yep, long scales. Something like 8 of them. These are very similar to the ones on the front, but with double the precision.
What is RUM?
RUM, it stands for RHUMB, and it's the old name for logarithmic lines.
Oh, for crying out loud.
Yeah. So the table that you called it on the left of the front of the rule is actually a technique for measuring as accurately as 1/100th of an inch. So by using these diagonal lines here and on the other side, you can quite accurately measure something visually to 1/100th of an inch on a wooden ruler, which is quite a trick.
Was there any kind of sliding component on here to help you line things up?
No sliding component at all. This was used with a pair of dividers.
Oh,
period.
okay.
Yep.
Okay.
And one thing you'll notice is that there are some look like little brass tacks in there. Those are the places where one end of the dividers was most commonly put. So there's one at the end of every scale, because you're frequently measuring from the end of the scale to somewhere in there, and then from common points used within the scale. And that was to avoid wear and tear on the boxwood rule.
So yeah, it's like an anchor point, and they each have kind of a center punch to them.
That's where
to
the
help
point of the
anchor.
dividers go. Exactly. Yep. So with this particular one, this was also for a navigator. I've forgotten who the maker is on here, and I don't think it's marked. But this particular one was from the early 1700s.
Marking on the side?
No.
Oh, somebody put their name on it.
Yeah, most of these have a maker's name on them, but I don't. This one I knew the provenance of, so that is I could track back the owners of this all the way to when it was made. Came from England, made in the early 1700s, don't know exactly when, but probably around 1720, 1725. And it was used by a navigator. So he just did basic navigation calculations on this, which basically are add, subtract, multiply, and divide, and some trigonometric operations. And the sine times tangent is a particularly common product in navigation, so they use that a lot.
That's fascinating.
This one was actually used by a navigator for almost 100 years.
100 years of use on this, and it's still in really good shape.
They took very good care of them. This was the only way they could get those calculations done without really arduous by hand calculations.
You wouldn't want to lose this.
No.
Do you know where this came from?
I know all the owners of it, all the way back to when it was made.
No kidding.
Yeah, I've got them all. That's rare for a slide rule or any antique computing instrument to have the provenance of it, but this one I happen to. I only have a couple things in my collection that.
Do you need any kind of certificate of authenticity to accompany this?
No, there's no such convention in this world. But it's quite something when you have the provenance because it's so rare for anybody to have it.
That's neat. Now, you mentioned there was some significant value and appreciation to these.
Yeah, this one is not particularly rare, actually. There are several hundred examples of a Gunter's rule out there. The demand is high, but there's several hundred of them, so it's not particularly variable. The Nairn and Blount sector rule, on the other hand, is quite scarce. It's hard to peg an exact value on this, but this is probably worth $1,000, something in that neighborhood, because it's scarce and there's a lot of collectors for it.
Wow.
This four-sided slide rule is very rare. From this maker, there's only 5 or 6 of them known to exist. And I have no idea what the value is for this. I bought it from somebody who didn't know what the value of it was and managed to get it at a very good price. But the trouble is there are very few collectors of it. Right? There's probably only 25 or 30 people in the world that would be interested in buying it. So.
Now, you mentioned that you sold some things to the Computer History Museum. Any other museums that are on your shopping list?
I sold actually one thing to the Museum of London, another Gunter's rule.
Like the British History Museum?
Yeah. Yep.
Oh, neat.
Yeah, they wanted an exhibit on navigation instruments, the whole history of navigation instruments, and I happened to have something that they wanted. But that wasn't a particularly lucrative sale because that wasn't a particularly rare item.
Okay.
I happened to have the exact one they wanted, and I had 2 of them, so I gave them one.
And we've got a couple more things here.
I do?
This one's got an old leather case. Ooh, and it's brass and shiny.
And if you feel it, it's heavy.
That's heavier than my iPad.
That's a solid brass slide rule. Even the cursor is
Beautiful.
solid brass.
Beautiful.
There were only.
Listen to
one's
that.
quite
Slide that
valuable.
again. It's got a gorgeous sound.
This one is very rare for 2 reasons. First of all, there were only 14 of them ever made. And we know exactly how many there were because there was one made for each Japanese battleship in World War II. This was the Gunnery slide rule, and they each had one. And most of those battleships were sunk. And as far as I know, only 3 of these survived the war. And
So maybe there's some down on some shipwrecks.
Yes. I don't know what kind of shape they'd be. Brass under salt water is not going to be holding up too well.
Brass holds up pretty well, actually. I noticed the Japanese markings on the side. That's
Those
what.
are the names of the scales.
Okay.
Yep. And these are this slide rule is used to calculate the elevation of the gun.
How about that? How long do you think it took them to calculate some of these things?
Actually, for this particular slide rule, we actually know that the officers who were responsible, the gunnery officer who was responsible for making that calculation, they got their position by competing for speed and accuracy, and they have records of it. So they had less than 10 seconds to compute the elevation of the gun.
Oh, wow.
Yeah, they were very good at it. There's 6 calculations involved. There's 6 changes in position of the slide rule you have to make in order to make that calculation. They could do 6 positionings in 10 seconds.
That's amazing.
Or less.
It's a beautiful instrument.
Yeah, that's one of my favorites. I like that guy.
And that's the original case?
Yeah, that's the case. The manufacturer never made a case. This was actually made by the owner. It's a handmade leather case.
Wow.
I shouldn't say the owner, the gunnery officer on the battleship it came from.
Got a little something about the size of a pocket watch here.
And it's going to look a lot like a pocket watch. This is a circular slide rule. This particular one's called a Calculor Graph. It's a French-made one. But this was another kind of computing instrument that was used by the gentleman. Unlike the sector rules, this one was actually used. People use this widely. And if you watch me operating it, on the front face of it, the main knob, it looks like the winding knob on a stopwatch, turns the scale. And then if I hold this little button in, it turns the needle. And by using those two things in conjunction, you can pretty rapidly do a multiply or divide. And that's the only thing you could do on this slide rule, is multiply and divide. Yeah.
My first thought was, because it's a circular thing, it might be handy in calculating
Circles?
circles.
No, nothing to do with that. It's just a way of taking a long scale and putting it in a small amount of space.
Okay.
Yep.
That's beautiful. That looks more gentlemanly.
Yes. And these are not rare. There's lots of these that survived.
Okay. A Calculor Graph. I love the name.
One manufacturer.
It sounds very steampunk.
This is a much more modern one. This is from the, I don't know the exact date, late 1800s, early 1900s.
This is a bit larger, too.
Yeah. And this was one of the first sort of well-made metal slide rules. Circular slide rule again. It's got log and sine scales, cube and so you can do cube roots and square.
Oh yeah, interesting windows to read off of the back. Now, is this aluminum frame?
It is aluminum frame, made by a Swiss company with an English guy by the name of Stevens, who started it using a French patent to make the slide rule. So it's kind of.
And there's something else tucked in here by the ruler. What is
That's just
that?
a ruler. It's a centimeters ruler.
Is this a knife?
No, it's designed to hold it in your hand.
Oh, okay.
Just a handle.
It's a little handle.
Yeah.
I thought it was like a Swiss Army slide rule.
And no, this is
Comes with pick, corkscrew, and calculate sign.
multiply, divide, signs, squares and cubes.
Why does it say made in France? I thought it was a Swiss or a what did you say, Swedish company?
Swiss. The company that made this is Swiss, but they had the case, the metal case here, manufactured in France. They were right across the border from France, so there was pieces of it being made in both places. But the patent is French. But the guy who owns the company was British, Stevens.
Very international. What is the patent number on there? I thought I saw.
Don't see it.
Okay, I thought I saw a very short number. Fewer patents back then.
Yeah, not that many fewer. There are a lot of patents, both U.S. and international, for slide rules, though. Hundreds of them.
Looks like a red alligator case.
I think it's fake alligator. I don't think it's real.
Simulated alligator.
Yeah. This one was typically the big market for it was college students. Right? They sold many thousands of those guys. The last thing I have here is much more modern. This is a Curta calculator.
What is it?
This is like the first digital calculator.
First digital calculator.
Yeah. So this add, subtract, multiply, divide.
Okay.
With, I think it's 15 digits, no, 11 digits of precision.
At first it looks like some kind of bomb detonator.
So I just cleared it.
I turned the crank. Kind of like an Etch-a-Sketch.
I forgot to raise this. Let's see.
Okay.
I've forgotten how to use it.
And there's no PDF on the internet.
Oh, there is. I have the manual.
Oh, yeah.
Oh, there is. Yeah. There are something like 5,000 of these have survived. There's a lot of these. Yeah, they're not rare. These were mostly used. The big market for these was car rally in the 50s.
Now, I seem to recall seeing something similar at the Computer History Museum, only much larger. You put in some numbers and you turned a crank and out came your answer.
I didn't see that there, but I don't doubt it. There were a lot of mechanical calculators like that. But this one, as your listeners can't hear this, but if you see it, it's quite small. Easy to hold in your hand, and the car ralliers did their calculations on this as they were driving down the road. Yep. Little tiny guy.
Made in Liechtenstein by Cantina Limited Marin. Oh, it's got some engraving on it. Somebody personalized this?
Yeah, that was the owner.
Okay.
Yeah.
So, and around the sides, it's got little sliders to choose your digits.
Your values in.
Okay.
Right? So if I want to add 231 to something else, I dial it in there, turn the crank once, I put the other number in, turn it again, I got the answer.
I'd love to send that to school with my kids. How many digits? 10?
11.
11.
11 digits and 22 answer.
That's amazing. Can we use our calculator on the test? Click, 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 crank, crank, crank.
Look at that. The threads on the case are backwards.
Oh, I wonder why.
I have no idea.
There's got to be a reason for that.
No, it's a restaurant.
Because it's Liechtenstein? I don't know.
It's European. It's like the buttons on the shirts, too. Well, Tom, thank you very much. It's been amazing.
You're welcome.